Hey man, you ever look into flat earth?
All right, I took this video of the sunspot a little over 7 days ago, 8 days ago to be exact. Florida's been real cloudy, hot, rainy. Haven't been able to do much as far as doing any observations. Humidity is high, so when I go out to the park I go to, it's pretty tough to focus in on anything, and a lot of stuff is just so distorted. And that's one of the things I wanted to mention was distortion. I get comments from Globe people that say I don't know how to use a camera, it's distorted, and blah blah blah. You don't know, you don't know what you're doing, you don't know what you're talking about. Well, if I can zoom in on the sun that's supposedly 93 million miles away, and not only can I see the big sunspot, but I can see the little tiny sunspots that are supposed to. That little tiny spot is supposed to be the size that Earth is compared to the sun. Now, if you believe that, um, you know, keep reading your science books because they're going to tell you the truth. They got all the answers for you. Don't use your own critical thinking and go out and test this for yourself. Just accept and believe what they tell you. That's the one of the big things that we all done. I mean, in the past, is we get taken to school and told to listen to the teacher, be a good boy, listen to the teacher, and learn because we don't want you to get absent fail. Um, So here's one thing is if I can zoom in on this, I shouldn't have no problem zooming in on a boat or land or anything out across the ocean, right? Well, yeah, there's what they call distortion, atmospheric distortion. It's really more or less like turbulence, hot air mixing with cold air, and also with the hot air, what do we got over water? Evaporation rate. And evaporated water is water. It's water. And can water reflect? Yes, it can. That's why you see the Fata Morgana. Um, but here, let's get to this. This is one of the places that I filmed from. This is like a little boat ramp at the park that people bring kayaks out there, and they can launch them from this boat ramp. But this is a spot, and it's about 20 feet wide, and I filmed from there. And you can always see this palm tree right here. So I could be off to the left, off to the right. Um, but I've also taken this from a whole bunch of different areas. One of them is I get up on top of the observation deck, which is only about 3 foot, 3.5 foot off the sand, and then there's a seawall, maybe 3 feet there. So standing on top of this deck, I might be 12 feet above sea level. But you know, we're talking about permanently placing your camera and looking at a fixed object. Um, at 27.6 miles away. And I get all these different effects. Sometimes you can't even see. There's another tower that's supposed to be between the big tower on the right and the smaller lights on the left. But there's supposed to be another tower there, and I go, oh, well, maybe they tore it down or something. Maybe they did some construction, but no, no, it's still there. It's the atmosphere is creating like a curtain effect. It's illuminated. Light pollution illuminates the haze, and then you cannot see it. Just like in this picture right here, you can barely see those towers. Now I'm more over to the right. I'm probably over by the observation deck here. That's why this light is now shifted to the left. Um, and that's why I picked out. I mean, I've been filming this thing for like 2.5 years, pretty much since I got my P1000. And I wanted to document pictures. I got a lot of video too. And again, sometimes you cannot get a focus when there's a lot of atmosphere or I don't even weather conditions. Evaporated water, wind. It all plays a role in and what you're going to see optically. Um, because, you know, even with my naked eyes, I can see this at night. I can see the lights flashing. And then there was one night in particular that's going to be in here that I had really, really excellent visibility, and everything fell right in place where it should be. Um, this is like a magnification effect, and anybody that knows, you know, stick a magnifying glass up in front of your face, and you got to move it back and forth until you get it focused where you want it. Well, sometimes you just cannot get it focused where you want it because you can't, you know, get your camera in the right position or at the right distance. And then you got that distortion, so you cannot focus in on it. Um, Now I'm going to point out this palm tree here, or this yeah, the palm tree, and there's a dead palm tree branch sticking up right where the pink arrow is at. Um, Now the bad thing about me filming on top of that deck is people come up there, they stomp their feet, they stomp the sand off their feet, gets the thing shaking. So I try to go there when it's not so busy. But here's another really awesome picture. Again, this is from on top of the observation deck. I can tell because the signs and the sign, I'm above that sign off to the right of the screen, if you can see it. But I've also taken these pictures and ran them through some filters, enhanced them, trying to get a little more detail or better visibility on them, clarity. Um, and it does work on some of them. Some of them are just so out of so distorted you can't make out shit. But you know, here you're able to see all these lights, and people say, "Well, it's refraction pulling it up." No, actually, it's refraction that's hiding it. Refraction works the opposite way that they're telling you. But see, people are so stuck on it, they'll defend it with everything they've got without going out and testing it for themselves and looking at really what they're observing, and then looking for these small details. That's what I do. You know, and yeah, I've had a bad attitude in the flat Earth community because I don't know. I guess I should. I expect everybody to see what I see, but you know the thing is I get to watch them in slow motion, over and over again, and I look for those details that I would normally miss if I've run it at regular speed or if I speed it up to go through the video real quick. Um, so again, you know, when you see these pictures here, and then you start making comparisons, and you say, well, I know where I'm standing at. Why one day I can get in that same spot, and I can't see none of this, and then other days I get in it, and it's clear as hell. I mean, it's very clear that this is there. It's not being bent, magically bent up, because everything else would get bent up in between me and there. You know, we got concavers. This is a picture that I took about 4.5 miles closer to the power plant. And, um, you know, when I compare it to another island, Hernando Beach Island, that's 4 miles away, it's really strange that I would even be able to see any of that, being that I should only just be able to see the tip tops of this if curvature was involved. But what I also notice is sometimes these towers will look bigger, wider, but short and squatty. Um, Sometimes too, I realize that the land in front of me is also getting. That's a bad picture. Also getting displaced. In other words, it's getting stretched up, especially when there's mirroring occurring. Right here, there's mirroring occurring, and it's displacing the land right there upward, the surface upward, and then the farther object, which is the towers, they get pulled downward. Um, really not so much pulled downward, but magnified. And when you magnify an object, it magnifies it in all directions, not just the top of it, not just the sides of it, but top, bottom, and side. It just gets larger. So by this happening, it's like having multiple different lenses that you're looking through. Um, and here's another time lapse that I took. Now I'm probably, well, I can tell where I'm at here. I'm in front of the observation deck on the beach. on the sand part. So again, I'm, you know, sea level should have nothing to do with this because I'm in a permanent fixed position, and the object, the power plant, is in a permanent fixed position. So the only thing that changes is that is really the atmosphere, the weather conditions. They change, and that's what causes us to not see things a lot of times. Like I said, you would not see this smoke if it was not illuminated by the lights there. You wouldn't see it at all. So you know, with the light reflecting off of it, we're able to see it. And that's why I say when it's a hazy day, again, you don't see the other tower there because it's hazed out. It's like dropping a curtain down just behind this tower. And if you go on Google Earth and you actually go to this power plant, it's called Crystal River Power Plant. It's on the west coast of Florida, um, up between uh, Citrus and Levy County, real close to the county line road, but I believe it's still in Citrus County. Um, and you can look at this and say, well, where is that other tower? Again, you know, at first I thought it had gotten knocked down, but you know, here you look and you can hardly see anything. You got to actually zoom in to see it. With the naked eyes. You're only seeing a little bit of flash of light, and that's it. Now, what's really funny though is I go past Hernando Beach in my fishing boat. Um, Now watch this displacement. Watch how everything shifts right here. It's not me moving the camera or these lines, but everything shifts because things get compressed. They shift further apart and get pulled down. So everything's being pulled down and shifted outward. And then again, like I say, you don't see that other tower there at all, but it's there, and you'll see what I mean. Well, as you look through the pictures, you'll see it. If you don't see it, then really there's no help for you. But because it's farther back, it's the farther towers. Um, I think what it does is it's being down, so it's being magnified so much, it's being pulled down beyond your visibility. That's another thing too, visibility limits. You know, go and check out what visibility limit really means. You know how they determine your visibility for a particular day. Now, some of these I try to change the lighting on them, brighten it up. You know, see what I can see. If it's more light, less light. But I find less light is usually better um, because you're not. Um, you know, if I put on a long exposure when there's lights, when there's still some light in the air, I just get a big white picture of whiteness. You know, maybe a little darkness, but you know, mostly it's just so whited out you can't see nothing. But your weather conditions have a lot to do with your visibility, and also, you know, without the proper visibility, without good visibility, you lose your angular resolution. And then also when you have this mirroring effect occurring, that also ruins your visibility and your angular resolution. So really what it comes down to is your, um, see that what I was doing there is showing you where I was standing. Now, see, I'm standing right by that observation deck, but I'm down at the bottom. I'm not up at the top. I'm down low to the water. Now, most of the time, I'm down at 28 inches with my camera. Um, it's yeah, standing for a long period of time hurts my back, so I'm able to kneel down and work my camera and kind of sit on my heels. But um, every time I move, everything in the background moves from those trees. Um, so when you start comparing these, and you say, well, why is this? Why, well, right here? Why can't I see that other tower? Again, it's magnified, pulled down, and it's also probably hazed out where this haze creates that curtain, just like dropping a curtain down behind you, behind everything. You don't see it. You only see what's in front of that curtain. So, you know, seasonal curvature. Well, we know different seasons we get better visibility than we do during other times when it's real hot and humid here in Florida, I get a lot of distortion. And it's like turbulence distortion. It's like the wind's mixing with the cooler air, the water's mixing in with that too. And it does create um, a magnification effect. And again, sometimes you cannot you cannot focus on distortion if the object is in distortion. And I had one guy, he's sitting there telling me, oh, if it's distorted, then it's being refracted. Oh, it's refracted if it's distorted. Well, man, I got pictures of stuff that it's only a mile and a half away and it's all distorted. So, and I'm up 10, 12 feet. Uh, that shouldn't be happening, right? So again, here's um, where again, even this land in front of me here can be magnified and raised, not only raised up, but it can drop down. Um, because again, that's how magnification works. If you just look at a magnet or magnifying glass and check it out, you'll say, "Oh, wow." And I've got some tests that I'm going to do. I'm a kind of a procrastinator. I get these ideas in my head, and then between my business work and yard work and all this stuff going on, I don't get a chance to actually do it. But that palm tree right there is, I use that as a key because sometimes you'll see um, the dead palm tree stump higher than the palm tree itself. So what's happening there? Things get stretched, things get compressed, and things get um, widened out. Like right here, you see that the stump and you see the palm tree. This is how I know I'm more to the left of that little boat ramp area. But when I get into that boat ramp area on the right day, right time, right visibility, I can see really, really well. Now, again, right here, I'm probably up on top of the observation deck. I'm not really sure. I don't go up there a lot because, like I say, a lot of people are up there walking around and they stomp and they don't care if you're filming. And they have no idea that you're using a zoom camera, so they don't know what it'd do to. I mean, it makes it look like a bowl of jello, like you see on some of the time lapses. They're wiggling, and it also could be wind too, because when it's real windy out there, it will cause your camera to move a little bit. Um, but again, you look at these towers and you're saying, oh, wow. Now I can see that the big cooling tower much higher. Now here I am on top of the deck because at the bottom here you can see the wood of the deck. So on that particular day, I was on the deck. Now this is a different day. And you see how it looks like it's down more. Now I'm not putting my camera um, I tell you, I put my camera in different locations to see what kind of results I get. And it seems like sometimes you can get closer and lower and get a better picture than if you get up higher. Why is that? Because maybe at the surface there's cleaner, drier, cooler air, um, and you don't get this magnification effect. That's why I say if you look at the trees and the details, that's what gives it away for me. I am one that really, I've been studying my footage. I watch it almost, I mean, I watch my observations more than I watch TV, because really, it's all about observations, and observations is the biggest part of science because if you don't observe it, I mean, you don't know what your outcome is going to be in your experiment. If you're doing an experiment, you got to see the results. So that's why I do a lot of observations. I mean, I spend hours out here on the beach sometimes, and it's crazy. Now I've got a lot of footage too that lets me know more about where I'm placing my camera. But I know if I place my camera too far to the right of that little boat ramp area, um, I get a different view than if I go to the left side. When I go to the left side, again, everything shifts. This I'm probably up on top of the observation deck. That's why you see it wiggling. But the ones that get me are the ones that I know exactly where I'm at when I'm in that and that little boat ramp, and I'm right next to the water. Now, I put out a video one time, showing this power plant, and it was some of the best visibility I have had here in Florida, where you can pretty much see, like there's other pictures, the lights in the parking lot, but without so much mirroring. Um, the land could be magnified, and if that gets magnified, it upward and downward. And then you have, these combination of effects when there's heavy mirroring or when there's too much light. There can be always too much light, where you've got to use your compensation exposure to turn it down. I mean, I've been out there where you couldn't see none of these towers at all. Does that mean they fell off the curve? I mean, look at here. Here's that palm tree up higher. Uh, Very strange to see another palm tree in there. Um, it, it's really hard to explain this to people because they don't realize these optical effects that occur can create all kinds of issues. Now, people that say, "Oh, well, when you're getting your best visibility is when you're getting refraction," I doubt that. This was a really, really cool night here, and I really wish I would have spent more time zooming in on that power plant. But I was out there really filming the lightning that was way off in the distance. I like to film the lightning from a distance instead of being right in it, because when you're right in it, you're standing a chance of getting hit by lightning. Um, but you can see how I run these through these filters to try to give myself the best visibility. And there's that other tower right here on the right. You see the one, and then you see the other one. Um, so again, where does that tower disappear to at times? Again, it's just like it's a curtain falling in front of it and blocking you from seeing it, or the land itself is, these trees is getting magnified upward, and it's getting magnified, and again it gets magnified enough to pull it just down below those trees where you don't see it. um, Pretty strange stuff. Now what I'm going to do here in the future is I'm going to pick me out a spot um, at the park. I'm going to make myself a little table or something that I can mount my camera on and just set it on the seawall from one position and take pictures like this like every day. So again, nothing changes. I'm on at a fixed position. And then of course the power plant's at a fixed position, and we will see all of these different effects that occur. And I say that if this is refraction, it's hard to believe that anybody can even accept that something beyond a curve, especially when there's a landmass in front of it, is going to be pulled up and brought directly into your face or your line of sight. Yeah, and I forgot to mention, sometimes I take pictures with, there's another setting in the P1000 for time lapses. It does time lapse pictures, and I use like the lightning setting, or not lightning setting. But anyhow, it takes pictures, and it doesn't put the date on the picture. So when you see these without dates on them, it's because I'm in that different mode. Um, and again, too, look at the lighting on here. When things are magnified, the lights look bigger. When they're not magnified, the lights are smaller. They're not so much glowing and expanding outward. Um, so again, you know, light can get magnified, and when light gets magnified, like the sun, again, it's bigger round. And that's why I say when we're watching the sun set, it's actually not really setting. It just keeps getting magnified, magnified, magnified. The more layers of magnification goes through, that's why it maintains its size. And people will, oh, you can't prove that. No, I really can't. But that's what I suspect that happens when I see this magnification done on these smaller scales or on less distance. I can imagine what it would do on the sun at a longer distance. Now, how far away is the sun? I don't know. I've never been there. I never taken a tape measure up there and tried to measure it. So, when science says it's 93 million miles away, it's just uh, an educated guess, really. And, people buy it because they don't consider themselves smart enough. So they just accept these people that claim to be so smart. They just accept their explanation for it. Um, and, that's again, we get sent to school. Our parents used to tell us don't talk to strangers, but then we get sent to school to a bunch of these strangers that are going to teach us um, uh, all this stuff. And here's the pictures that I was telling you about. Now, this was done at 28 inches off the water. You can see the palm trees. You can see all the towers. You can see the lighting. You can even see some of that building on that far right tower, the top of that building. Um, so, yeah, this was again like one of my best days of visibility, and it's like, are you kidding me? I mean, I can see this with my naked eyes, and that's why I stopped. I was fixing to leave the park. It was fairly late to me. It was. I mean, I needed to get home. I don't even think I ate dinner that day, um, so I wanted to get home and eat dinner. But here's that palm tree, and you can see where everything's setting. So remember some of them other pictures when I was in this same position, you can't see it. And I've actually went up higher. Um, like there's a sidewalk at the park. I get up on that sidewalk, which makes me higher than where I was normally at, and I get this type of picture right here, where everything's down below. I mean, it's crazy to think this, but here's where I'm sitting at, and here I'm gonna slowly zoom in. Um, and take pictures as I zoom in a little by little. Sometimes I zoom in a little bit more. Um, change the setting on my camera, or actually this I changed it in the um, oh when I put up a picture, I'm able to use filters and um, enhance it, brighten it, lighten it, more contrast, less contrast. Um, and usually when you see the lettering um, of the date and time, if you see that changing colors, it's usually orange. When you see that changing colors, I'm usually changing the filters or enhancing it so it does look different. But look, you can even see way off to the right another um, some other power plant or some other area right there. Um, but again, I move over to the left. This is what I get. uh, and again, you can see this surface mirroring just below those other towers right there to the left. But again, look at how big the lights are. The land, it's hard to focus on two things too. You're focusing either on that land or on these towers. Um, so it's all in, your. I don't want to use brainwashed mind, but it's in your belief that as you went through your indoctrination or your education system, that you had to accept it all. They gave you the answer, and then you just had to memorize and repeat that answer like a parrot. And as long as you are a good parrot, you got your cracker. Okay. And if you are really, really good, you get to become an educator yourself and become a teacher because you just proved to them that your memorization and your parroting um, skills are really good and they're really going to work well for you because we want everybody taught the same. We don't want no critical thinkers. We just want people smart enough to do the job that they are meant to do, and other than that, they don't give two shits about you. You really think the government cares about you? Yeah, right. Stop paying your taxes. You see how much they care about you. All right, thanks for watching. I hope this helps, but I got another one coming up that's better.